The objective of this video is to let you know that how algebra helps you to develop a critical thinking, abstract thinking, and trains up your mind into solid logical reasoning and other skills. Now you might be wondering that why in this video I'm talking today of algebra, because algebra is something which we have learned in our school days at a very basic preliminary level. But yes, in this video I'm going to take you through a fascinating journey, certain points probably which you don't know, through which you will come to know that how algebra helps you into developing your mind and training up your thought pattern into different other skills which might not be very relevant not only to mathematics, trigonometry or other things, but it might be very useful in other spheres of life. This is a video which is going to give you a complete, detailed and a deep insight into the benefits of learning algebra, and it might even happen that you go back to your school days and brush up your basics of algebra, because algebra is something very crucial and very root at the foundation of mathematics, which gives you something into abstract thinking, critical thinking, and develops and trains up your mind and your eyes into different other things. My name is Shaunak and you're watching this video on my channel Physics for Students. Season's greetings and a warm welcome to watch this video. Now, if you note the first point which I have mentioned, that is, it is the art of accumulating things together. Now, what do I mean by that? Now, the very word and it means collating or accumulating things together. Now, when you are trying to accumulate things together, what really happens? Have a look on your screen. Now, when you see this type of equations, 5x squared plus 9x plus 12y and so, and you see next 12t plus 13y plus 7x squared, and you then see a third one and then a fourth one. So what happens is that when you go forward in solving those equations, what you do is that you accumulate and take things and sum up them together. You make all the x's at one side, you make all the y's on the other side, or maybe you cancel out the t's and the s and the b's, and then you find out the equation which ultimately yields to the final result. You find the value of the unknown. It can be x, s or t. So what I'm trying to make a point over here is that this particular idea or this particular skill is very helpful into other spheres of life. For example, even if you're taking mathematics, you're going further into geometry, you're going to calculus, you're going to differential geometry. Accumulating things are always necessary. Now, if you go into further, complex studies of patterns, shapes and structures, you will see that at some point of time, you will have to accumulate things together. That means you have to take things together which are of similar pattern, and you have to take all those things together which are not of similar pattern. Now, for example, if you are dealing with quantum mechanics or advanced topics in physics like general theory of relativity, solving big equations like geodesics or Ricci scalar, or even going into quantum mechanics when you are calculating probabilities, dealing with subatomic particles like electrons, protons, or you're solving pure mathematics like real analysis, complex equations, you will always find that this pattern of accumulating things are there. So the first point is now quite clearly established that the word algebra means accumulating or collecting all those broken parts. So as you see, the equations are always broken. In examinations and in other spheres of life, there are always things which are broken, and we as human beings, we have to solve problems. We have to. So don't you think that this is a very philosophical point and a very deep-rooted point in the mind of those who are slowly being trained in mathematics, that you really learn the art of accumulating things together? In our daily life also, in a life as a teacher, as an entrepreneur, as a physicist, you will get things which are broken. You will get problems which are totally broken. And this is the first step, that you start to learn to how to accumulate things together, how to gather things together and thereby give the solution. So the very word algebra and algebra, it comes from the word that the broken pieces are now being meant and calculated together. So in the second part, we talk about abstraction. Now, I got a lot of comments in my channel where my subscribers and dear friends, they are asking me to create a video on how to improve abstract thinking, how to improve critical thinking. I really appreciate. I'm trying to find out a time where I can create a video on how to improve abstract thinking, because abstract thinking is something which really bothers the mind of young people or candidates venturing their career into teaching. But algebra is the first step towards abstract thinking. Why? Just have a look on your screen. So you see that whenever you see a function or something like this, fx equal to x squared minus 5x plus 7 and gx is equal to square root of x. And then you see something in fraction, and then you see a function k of x equal to x squared. So as soon as this type of a thing comes in front of a student, it is a problem. Right? If you're given numbers, there is not a problem. But if you're given symbols and all those square root and x and y, and then you need to find out, you will see that there is a problem. There is a kind of a thinking, a change in the type of thinking that what is this? What is this all about? I'm unable that you will be doing abstract algebra, group theory, knot theory, combinatorics, probability, all those. But this is the first step which you take in learning algebra, that you start learning abstract things. You start trying to visualize what is f of x, what is y, what is t. So on the other side of the equal to, if that is there, then how I can bring it to the right hand side. I hope I can make things clear. So this is actually the first step, because the number ceases to become numbers and they become variables. The expressions are no more expressions, but they are abstract things. The numericals cease to become numericals and they become something like x, s and t. And that is the beginning of the confusion. I'm going to say it is okay to make errors, it is okay to make confusion. But the basic thing is that what happens is that you take a first step, and a very first step towards learning abstract thinking. And that is absolutely fine. I mean to say, at some point of time, we really have to start in order to do abstract thinking. But algebra and those variables is the first step. So do not ignore algebra if it is in your early school days, or even if you have to now go back after watching this video, that let me see how abstract thinking really is being rooted ground to the basic foundation of algebra. Yes, I would like to tell you, absolutely it is. And this is the first step towards learning abstract thinking. So we come to the third point, which is very important. You learn to simplify complicated problems. Now, this is something which starts with the very basic simplified equations of algebra, and it takes a step forward and you go and learn how to simplify complicated problems. Now, you might be saying that we all know that, but hold on. What I'm trying to make a point is that this type of an approach to solve critical problems, or I would say you're given a very big problem and you're simplifying those into further steps, actually helps you to deal with further difficult problems. Right on your screen, you see I have given, if a square plus b square equals to 1 and c square plus d square equals to 1, then you have to find the value of this expression. So what happens is that in this type of a particular problem, you rewrite those into step 1, steps 2, step 3 and so on, and possibly you can also write the formula which you know, and thereby you can find out a solution to the problem. So what is happening is there, by learning algebra further and solving big problems or big equations or expressions from algebra, what you really learn is that you create a kind of a intricate problem solving knack. You develop something that in further, for example, chaos theory or an industrial problem, or a problem which really demands that you need to break that down into several simple steps, and then you need to learn. This is the approach. Because you will see that, again, I am taking few examples of knot theory, group theory, even in physics when you deal with thermodynamics, cosmology, for example, relativity, etc. There will be big equations. There will be huge equations which you might find, oh my goodness, how I am going to solve it. This is the first step which algebra actually teaches you, that how you break down a problem into simple steps. Write down those which are known, write down those which are unknown, and then you solve for the unknown. So this is a very important, I would say important point, that you really write down those steps. So remember that even when you're learning algebra at your formative years in school, maybe in college when you're taking up abstract algebra, those things which you think that it is too simple, I'm to say what is in there, there are a lot of things in there. The most important thing is that you are developing and training up your mind to learn how to solve problems, to break down a typical problem. Now this problem is not only to mathematics, it can be physics, geography, statistics, anywhere. Even in our life, in our day-to-day life, we get a lot of problems. How we can break down that particular problem and get into a particular solution, algebra actually teaches you that. Now this point is something which is very true. I think that I don't need to explain further. It improves the power of logic and reasoning. Because once you're given a kind of an abstract equation or an expression, and then you need to solve it out, so you really know, oh, okay, so if so and so equals to so, and then from there you deduce further, you go into further solving the equations, putting the known, taking out the unknown, solving for the variables, etc. So yes, it definitely develops something which is called the power of logic and reasoning. Now obviously when you're learning philosophy, the power of logic is more strengthened. Different rules, the power of the 19 rules of logic by Copy, and then you understand those operators of logic and finally solve a solution. But try to understand that algebra also gives you quite a number of options in order to improve your logical reasoning. First are the unknown equations, the unknown variables, the thing that you really know versus the things that you really don't know, and further. So yes, it is very important that algebra helps you to develop logic and reasoning. Now this is something not only great, but this is something really beautiful. So you find out the wonderful creation of symmetry. Now what I'm trying to make a point is that in algebra, when you're solving those equations, you will see that even a very big equation or a complicated equation, they have something which is similar, and that carries a beautiful symmetry. Symmetry is around everywhere, right in this room, out there in the hills, out there in the ocean, or you're walking down a path in Switzerland, or you're taking photographs of the sunset down the bank of a river. Symmetry lies everywhere, and you really need to see or have the eyes to see the symmetry of God, the symmetry of nature. And algebra actually teaches you that. Right on your screen, I have just given a simple example. For example, you're solving for this 3x equals to 10, this, and then you got 4x. So I've just, made a red mark on those 3x and 4x. This is very simple. I think it is a class 3 or 4 problem. But what I'm trying to make it a point is that you see those beautiful symmetries. So, the 3x at one side, then the 4x on the other side. So you start seeing those symmetries in algebra, in those equations. And further, when you go up to the ladder, when you start dealing with dimensional analysis and things which have got further dimensions 3, 4 and 5, then these dimensions actually carry a kind of a symmetry. Symmetry around the nature is everywhere. I think Noether's theorem is one of the biggest example of symmetry. So algebra actually teaches you a lot into symmetry. You can see right on your screen, I've just given a very basic formula of a square minus b square, a plus b whole square, and so on. But if you see onto your screen right now, you will see that there is a symmetry. The longer the equations, cube and 4 and etc., the right hand side changes accordingly. So isn't it beautiful to look at those symmetries? Algebra teaches you those symmetries, and again I'm repeating this point, that once your mind and eyes and brain is trained up in watching and finding out those symmetries in equations, then you can find out the symmetries in the nature everywhere, and then you really start enjoying the creation of nature, or even if you call God, that how beautiful he has constructed this nature, that the beauty of symmetry lies everywhere. Yes, it helps you to understand the relationship between patterns. Now, when you are growing up the ladder from algebra, you're going into geometry and you're taking Euclidean, non-Euclidean geometry or any part of physics or mathematics, identifying patterns is something which is very crucial. I have seen in my college and even the graduate days, even today, you will see that students really are suffering because they are unable to identify the patterns. Why? Because there is a lack of visualization. Why there is a lack of visualization? Because they are unable to see the pattern. Maybe their foundation or the way they have done mathematics is not right. Right on your screen, I have shown you just a few examples that, for example, x plus y equals to 2 and so on. So if you see in the first, this is something which is missing in the equation. What is missing? Let me show you. So here you see I have just put up the coefficients, although it is not required. 1x plus 1y plus 0 z equals to 2. Then I have put again 0 in front of x and 1 in front of y. Again minus 1 in front of z and so on. Because I need to find out the symmetry. So I have written that something times something plus something times x plus something times y plus something times z is equal to something else. Right. So I am putting the coefficients in front of those equations. Why? Because I really want to find out the missing symmetry. Now you see I have put those on a kind of a matrix. Right. And this vector x, y, z, and there is a matrix and it actually creates a beautiful pattern. If you watch this film called Matrix, where Morpheus says that matrix is everywhere, it is right there in front of you and it is right present in this room. So yes, it is true. You can now take this matrix and you can further extend it to anything, to weather forecasting, to finding a fluid dynamics, you can finding a metric of space-time, you can use those matrix to calculate linear algebra, you can do a lot of things, right? So why is matrix? Because matrix gives you a symmetry. And once you get a symmetry, it becomes easy for you to do the calculation, isn't it? And where from this symmetry comes? That's algebra. So this point is very important, that when you're learning algebra, it is not just you're learning algebra, you're just doing the equation and getting a good score in your school or university. You are learning the secret of nature. You are learning what is called the beautiful patterns, the symmetry of nature. And once you start identifying those symmetries, you will see that you are enjoying everything, and most importantly, the mathematics of algebra. Yes, this is something which I am still, I would say I am learning, that you train your eyes and minds to recognize patterns. So when you are given a very big kind of an equation or a mathematical expression or anything like that, so what happens is that you really don't always solve, right? You really don't solve those problems. So if I say something like, for example, 2x plus 5 equals to 3, then would you really work out on a pen and paper to find out the value of x? You won't, right? Because you know that if I put the constant on the other side and then I can solve out for x, something like that. So yes, so algebra actually gives you that first initial step, that you train your mind and your eyes to recognize. You really don't have to solve the problem. You really don't have to take a pen and a paper and find out the value of x. Immediately by looking at it, at least some part of the problem is being solved. For example, right on your screen, I have shown you 2y plus 5y minus this and this, are they similar? So both of these, are they similar? I know that you will have to take out a pen and a paper, but at least to some extent you can say that, okay, it seems that they are similar, or it seems that they're not similar. Why it seems to you? That is what is called a mathematical intuition. And how does the mathematical intuition develops? It develops through recognition of patterns, and most importantly, you train your mind and your eyes to recognize those patterns and equations. Once you identify those equations, once you recognize that what is in, what is out, you take less time to solve those equations and you become a master of that, and thereby you make things slowly. So most importantly, here you are training up your eyes and your mind, and most importantly your brain and the dendrites in your brain to know what those patterns are, and you can recognize once you see the equation immediately. So the last point is that this helps you, is the first step towards generalization. Now I have talked at length about generalization in my videos on general relativity and especially on topology. So what happens is that when you deal with algebra, if I give you numbers, say 1 and 2 and 3 and 4, then they are just numbers. But what happens when you replace those numbers with English alphabets or Greek alphabets, then it becomes generalized. For example, 2x plus 4 equals to 25. You see on your screen, F equals to ma. And then you get the momentum's formula and the formula of pressure. So what happens really is that if I just give you the numbers, then the numbers won't work out. Rather, generalize the numbers into something which is called alphabets. So Newton's equation, F equals to ma, because we are given m equals to mass and a equals to acceleration, and we are not restricting the value of mass and acceleration to something which is numeric, it works everywhere. So we can use this equation to fluid dynamics. Wherever there is force, two bodies which are colliding, and even when somebody is punching on somebody, when a car is racing, and why you move forward when there is a sudden brake on a bus or on a car, all these are explained. So same goes with all types of equations. So algebra is actually the first step which teaches you to generalize. Now here comes something really important. What will you do with generalization? So once you move up, once you get into further difficult complex problems and mathematical equation, etc., you substitute those variables and you make one particular physical system which is working with one, and you may generalize and make it broad so that it applies everywhere. Just like, for example, a mobile was just a mobile 10 years or 12 years back, when it was just meant for calling. Now you see it has generalized into talking, making videos, calling WhatsApp, making video calls, watching films, being very active in social media, right? So what it has happened, it has generalized. Mobile phones, television sets, smart watches. So watch is no more a watch, right? So it is for even calling, answering to your wife's messages, everything. So the point is that algebra's variable, whenever you're learning, keep it in mind that it is basically helping you to a much broader and stronger thing. That means you're developing a kind of a mind and a brain in which you can take very big industrial problems and generalize them so that it becomes easy and applicable to. First step is towards generalization. This is the very crucial and the most important point, because I'm sure you will take up algebra, mathematics, physics, further up, further problems, big difficult equations. How do you learn to generalize and make a kind of a solution which is applicable to everywhere?
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.